Greetings, math fans. All right, so this is day 4 of probability, and we're going to do something that we've used a formula in the past. And in fact, just last chapter, remember when we did binomial expansion, and I had you guys find the middle term, or first I expanded, find the middle term, find the fifth term, given a binomial, like x plus 3 quantity to the 10th power, and you could expand it, you could find whatever term you wanted. Well, we're going to use that for probabilities as well. And as the word use the prefix as binomial, right? It's two terms. So we will use this for probabilities that have two possible outcomes. That's kind of what the title is here. Distribution right here is based on two possible outcomes. So here's the nice little friendly formula that we've already learned. P of x equals, right, this is a combination, nx, and then one, well, we kind of learned it this way, but it's basically P is the probability of success. So we're going to just kind of apply what we learned for binomial expansion to probabilities. Okay, so P is the probability of a success, and what is 1 minus P then? Well, isn't that failure? Okay, so this is a good way to look at it right here, and then we'll look at this way right here. But basically, you guys remember that x right here, that goes there, right? That goes with the second term. And then these two values here have to add up to that top term. So if this x goes there, then you just say n minus x goes with the first term. Okay? So n is the number of tries. So binomial, let's talk a little bit about what binomial probability is used for. Again, anything with two outcomes, like a true-false test, flipping a coin. And now, kind of an interesting one, which we're going to see a lot of, is if I give you a multiple choice test, is that binomial? Well, in some ways it is, and the reason it is because you either get it right or you get it wrong. Okay, it's not like you pick A and you get part of it right, and you pick B, well, you get a different part right. It's either you pick the right letter and get it right, or you pick the wrong letter and you get it wrong. So that is actually a binomial probability. Okay, so looking at this guy now here, again, n is the number of tries, x is the number of successes, and you always put your failures first, and the probability of failure first, right here, and the probability of success second. And kids sometimes get that confused. They want to put success first and then failure second, but I made up this quote here back in the day. Sometimes you have to fail before you can succeed. So failure first, then success. So again, this x goes here, and then it's basically n minus x. Okay, gives you your exponent for the probability for failure. Okay? Another thing I want to mention is success doesn't always mean it's a positive thing. If I said, what's the probability that we're going to have a huge tornado, okay, that's actually a success. Even though it sounds negative, it's whatever I'm asking for, that's your success. It's pretty important you guys understand that. Okay, so let's actually start out here with a nice little example. And you're going to round your answers to 3 decimal places, okay? So the last page of the last test consisted of 5 multiple choice questions. Each question had 4 possible answers, only one of which was correct, okay, which I was talking about before. If a student chooses each answer at random, find the probability he will get all 5 correct. So here's the deal. It's basically saying the probability of getting all 5 correct, and we remember the top number is the number of tries. So there are 5 questions, and I'm getting all 5 of them correct. Okay, and we're going to have remember this is our success, and this is our failure. And this is these are probabilities. So what's the probability of success? Well, think about it. If it had 4 possible answers, isn't it 1/4? Right? That's 1/4 is success, and 3/4 are failure. Now these are going to add up to 1. 3/4 and 1/4. They're always going to add up to 1 because either you're going to succeed or you're going to fail. Okay, there's nothing in between. Otherwise, if there is, then it's not binomial. All right, and then remember this 5 here goes here. The bottom number goes there, and basically 5 minus 5 goes here. Okay, and again, you put it all in your calculator. Combinations, make sure you use lots of parentheses. Make sure you put that 1/4 in parentheses and hit to the 5th power, because if you do, if you don't put it in parentheses, it won't do the top. Now this doesn't matter so much because 1 to the 5th is the same as 1, but it's just a good habit because if you have 2/3 to the 5th power and you don't put a parenthesis around there, it's only going to raise the bottom number to the 5th power, and that's not good. Okay. Anyway, the answer to this one is 0.001. So I want you to think a little bit logically about this question. It's saying what's the probability of getting all 5 correct at a multiple choice test that's got 4 possible answers. It's 0.001. It's 1/10 of 1% chance that if you randomly guess like a monkey, okay, you're going to get all of them right. So people that come out of the ACT going, well, you know, I did a lot of guessing, but I think I did okay. No, you didn't do okay. If you did a lot of guessing, if you didn't narrow anything down, you just like kind of guessed here and there, you probably got a horrible score. Okay? So if you can narrow it down and have, instead of 4 choices, you have maybe 3 choices or 2 choices, it actually makes a big difference. All right? But it's to try and guess at a multiple choice and get a decent score when you're guessing at a lot of them without narrowing anything down, it's not going to happen. You're going to get a really bad score. Okay, so let's look at the next one, probability of getting only 3 correct. So that's the probability of 3. And remember, there are 5 questions, and now you're getting 3 correct. That 3 on the bottom is the number for success. Okay, and these are the same. 3/4 failure, 1/4 success. And now this 3 goes here for success. And failure, it's 5 minus 3, which is 2. Remember, these numbers have to add up to 5. These 2 numbers have to add up to 5. Okay? And you multiply all that out, and we get 0.088. So now that's saying, yeah, if I get, what's the probability of getting 3 correct? That's about 8.8% chance. It's still pretty bad. Okay, it's still bad, but it's a heck of a lot better than 1/10 of 1%. Okay, it's actually 88 times better than getting them all 5 correct. All right, so it kind of shows you. Now, if I do probability of getting 2 correct, that'd probably be a lot higher. Probability of getting only exactly 1 correct, even higher, and maybe 0 correct might even be a little bit higher. Okay, there's a little balance in there of when you actually get the highest probability. Okay, let's look at number 2 here. The Chicago Bulls win-loss record going into the series against Utah in 1997 was 62 wins, 20 losses. What was the theoretical probability that the Bulls would win the NBA championship by winning 4 of their next 7 games? Assume all 7 games must be played regardless of the outcomes. Just, you got to kind of modify things a little bit. So anyway, I'm saying the probability of getting 4 games of their next 7. So I'm playing 7 games and I have 4 successes. So I'm going to put my probabilities here. Remember, this is success. And think about it. It's 62 wins and 20 losses. So total games, you kind of think about this one, right? Total games is 82. So you can't just put 62 and 20 in there. You got to actually put a probability. So success is 62 out of 82. Right? And failure, they have 20 losses. That's a record. 20 losses out of 82. Okay, and then the 4 goes here, and 7 minus 4 is 3. Okay, and if you do that, you get 0.166. So that's saying that they're going to win 4 of their next 7 games. Okay, about 16.6% chance. Okay. Now, if I did probability of 0, 1, 2, 3, 4, 5, 6, 7, if I did all the probabilities and I added them all up, what do you think all those probabilities would get to? If you guessed 1, you were right. Okay, because you're either going to win 0 or 1 or 2 or 3 or 4 or 5 or 6 or 7. That's the only, you got all the choices there. So if you add them all up, it's going to be 1 or 100% chance. Okay, so let's go on to number 3. A die is rolled 5 times. What is the probability of rolling exactly 2 4s? Okay, so the first thing you got to do is, first of all, the probability of rolling a 4 is 1/6. Okay, that's your success, right? And your failure is, of course, 5/6. So we're going to say, what's the probability of getting 2 4s, rolling it 5 times? Well, it's 5 rolls, and you're rolling it, or you're getting 2 4s. And remember, your success is 1/6, and your failure is 5/6. So the 2 goes here, the 3 goes here, because 5 minus 2 is 3. and we get 0.161. Okay, so again, you know, what is the probability? I mean, if you think about it, when you're rolling it, to roll a 4 and then roll a 4 again, and I mean within 5 rolls to roll exactly two 4s, I mean it's obviously about 16% chance, because sometimes you're going to roll more than two 4s and sometimes you're going to roll less than two 4s. Okay. Number 4, coin is flipped 5 times. What is the probability that you'll get 3 tails? So again, think of the probability of getting a tail is 1/2. So probability if that's success, your failure is also 1/2. So the probability of getting 3 tails out of 5, so it's 5C3. And the first one, this is 1/2, and of course they're both 1/2, right? And you have 3 here and 2 here. And so we get 0.313. Okay, that's not that bad, right? Pretty mellow so far. Okay, number 5, it says the probability of that a tomato plant will bear fruit is 0.6 if it is planted before May 25th, because you got to worry about frost, I guess. If I plant 5 plants, what is the probability that 0 plants will bear fruit? Well, probability of 0 plants. Again, I'm planting 5 of them, and 0 are going to be successful. Okay, and remember, bearing fruit at your success, that's 0.6, your failure is 0.4. So the 0 goes here, and the 5 minus 0 is 5 goes there. And we get 0.010. So again, think about it. The probability that a tomato plant will bear fruit, it's pretty good. 0.6 is pretty good. And if I'm planting 5 plants, the probability that none of them will bear fruit, if in general they should really bear fruit because of 0.6, that's actually a pretty low probability, because we're probably not going to have 0 that are going to bear fruit. It's probably going to be more than 0. It's probably 1 or 2 or 3 or something bigger. Certainly not such a low probability, or low chance, right? It's going to be a higher chance. Okay, probability that 3 will bear fruit. So of course that's just 5C3. Same probabilities. This is a 3 and this is a 2. And we get 0.346. See, you can tell it's higher, right? And all of them will bear fruit. Well, that's probability of all 5 bearing fruit. So it's 5C5. Now, what do you think? Is that going to be higher or lower than 0.346? I think it's going to be lower, because 3 out of 5 is about 0.6. So that should actually be the closest one to the probability of or the highest probability, because it should be about 0.6. Right, 3 out of 5. So anyway, let's put all this in here. 0.4, 0.6. This is going to be 5 and 0, and this is 0.078. So it is. It's lower. Okay, which makes sense, because the probability that their plant will bear fruit is 0.6, and all of them then to be good is about a 7.8% chance that they're all going to be good. Not high, but better than none of them working, right? So again, if I add all these up, if I did for 1, 0, 1, 2, 3, 4, and 5, it would add up to 1. Okay, number 6. If the winning percentage of the White Sox is 0.437, what is the probability that they will start the season winning 10 in a row? So think about it. 0.437, that's your success rate. So failure is, of course, let me just write this out here. Failure is 1 minus 0.437, which is 0.563. Okay, so winning 10 in a row is going to be 10C10, and your success is again 0.437. Failure is 0.563. The 10 goes here. The failure is 10 minus 0, which is, or 10 minus 10, which is 0. Okay, and that comes out to be 0.0002, which again, it really seems unlikely. If their winning percentage is not quite half, and for them to win 10 in a row, it's 0.02% chance that they're gonna do it, win 10 in a row. Very unlikely. Winning 6 out of 10. Well, that's probably more likely, right? So we're playing 10 and we're winning 6. And so we're going to do the same thing, 0.563 and 0.437. This is 6. 10 minus 6 is 4. And we get 0.147. So that's actually a little bit higher, right? About 14.7% chance they're going to win 6 out of 10. That makes sense. This next one is winning at least. Guys, you need to really look out for this word, at least. Winning 2 out of the 10 games. So what you could do is you could do 2, 3, 4, 5, 6, 7, 8, 9, 10. It would take you like 20 minutes to do this problem because you'd have to do, 2 through 10. That's a lot, right? Or what else can you do? So let's say we can write probability of 2 through 10. Or couldn't you do 1 minus the probability of 0 through 1? This is a lot shorter, math fans. Okay? So that's what you want to do. So you want to do 1 minus, and it's going to be, the probability of 0 is going to be 10C0 and 0.563, 0.437. So this is 0 and 10 plus 10C1, 0.563, 0.437, and this is going to be 1 and 9. So you're going to add those together and then subtract them from 1, right? So much easier. So just kind of be smart about it. And you get 0.972. So that makes sense. If their success rate is 0.437 to win at least 2 out of 10, it's pretty high, right? It's not like they're going to lose a lot of games. They're going to win at least half of them, I would think. But obviously in this case, winning at least 2 out of 10, it's almost 100% chance. Not quite, almost. All right, letter D is kind of an interesting one here. It's losing 9 in a row. So I'm asking you, this is what the question is. So losing is our success. Remember I told you that in the beginning. Don't always just assume that a positive thing is success. It's whatever the success is, whatever's the question, or whatever the question is. Okay? And the question in this case is losing 9 in a row. So what we're going to do is we're going to say, oh, if it's 9 in a row, it's 9C9, because 9 and 9, all of them, you're losing all of those. And now we're going to say our losing is our success, so 0.563. We're kind of switching around. And winning is our failure. So this is a 9 and this is a 0. I hope that makes sense. Whatever the question asks you for, that is your success. And you get 0.006. So again, probability of losing 9 in a row, it's pretty bad, less than 1% chance, okay? Which kind of makes sense because their winning percentage is 0.437. Okay, and then letter E, losing 2 or 3 out of 6. So again, it's just going to be 6C2, and losing again is our success, 0.437 and 0.563, and this is going to be a 2 and a 4. And remember, it's 2 or 3, so plus, of course, right? And 6C3, 0.437 and 0.563. And this is going to be 3 and 3. Okay, and if you add these guys up, you get 0.471. Okay, not quite half. All right. So anyway, that's it with binomial probability. Again, it's if there are 2 possibilities: a success, failure, like all these problems. Think about it; they're all successes and failures. Okay, so 2 possibilities, and you can use binomial. All right, that's it, math fans. Have an outstanding day. Adios. Goodbye.